In this video, we'll continue solving systems of linear equations using elimination. If you haven't already, definitely make sure that you've checked out part 1 for this video, as that will be essential to understanding what's going on with this one. So let's look at this example here. 2x plus 3y equals 12 and 4x minus y equals 8. So we could manipulate this, we could put this in a slope-intercept form and try and do some substitution, or we could try and use some elimination here. So if we're looking at the coefficients of both of our variables, we can notice right off the bat that they are not the same. Okay, but maybe is there a way that I could make them the same? And you could do this however you like. I'm looking at it and I'm thinking, okay, well, if I double my x's, that would make 4, which I could then subtract the bottom equation from. So if I multiply this entire equation by 4, and I can do that, I can multiply both sides of an equation by a number and still maintain the equality. So what we'll have here, or not 4, by 2, forgive me there, to get 4. So we'll have 4x plus 6y is equal to 24. I just double everything, and then I'm just going to go ahead and bring this bottom equation across. So we'll have 4x minus a y is equal to 8. And then what I'll do is I'm noticing, okay, they are the same, and I need to somehow make 0 x's because I need to eliminate a variable, so I'm going to subtract this bottom equation off. So the x's are gone. Cool. They've been eliminated. That's what we want to do. Okay, so we're going to have 6y minus a negative y, which would be the same as 6y plus 1y. So we'll technically have 7 y's here. And then we can subtract 8 from the 24, which is going to give us 16. So it's not pretty, but it does work. So this would tell me that y is going to equal 16 over 7. Now, I do have a choice here. I can plug in this y back in, solve for x. I could do that. I'm going to have to deal with fractions if I do so, though. So that'll be a little bit tough. The other option is that I could eliminate the other variable. So I eliminated the x. Now, if I kind of rewind here and think, okay, what am I noticing here? What if I triple this one? Then my y's would be able to cancel. So I'm just going to go ahead and rewrite this first equation just down here to make it a little easier for writing purposes. And then we're going to triple the bottom equation. So we'll have 12x minus 3y equals 24. And we might be noticing here, okay, we have negative 3y and a positive 3y. So then I can just add my terms. So I'll have 2x plus 12x, which makes 14x. The y's would be gone, and this is going to give me 36, which means that x is going to be 36 divided by 14. And if you felt so inclined, you could reduce. It looks like I can divide them both by 2, so we'll have, looks like 18 sevenths. But 36 fourteenths would also work. It's an equivalent fraction. So you've got options with systems of equations. You can plug them back in, you can solve, you can do it this way. And this method of elimination in this particular example, maybe it wouldn't save you too much time, or maybe it would. It all kind of depends on what you're comfortable with. If you like substitution, you can use substitution. There's no one here that's trying to take that away from you. You can do them however you like. This is just giving you another option, kind of illustrating another process that would be valid. So let's take a look at another example. So if I'm looking at this system, 2x equals 4y plus 2, and 3y minus 2x equals 10. This is one of those examples I kind of mentioned in the last video about how the systems need to be in the same format. And what I mean by that is if we look at this top equation, well, it goes x's, then y's, then constants. And the equal sign is, well, in between the x and the y's. If I follow that same logic, well, on the bottom equation, blue is y, reds are x's, the equation is underlined in yellow, and then my numbers are in green. I need to make sure that all these things are lined up correctly. in the same order. And that's what I meant by format in the last video. So what we're going to do is we need to do a little bit of manipulation before we can apply any of our elimination skills. So I think the first thing I'm going to do, the easiest way I'm seeing is, all right, what if I just move this 4y over here to the other side? And then we'd be all right. So I'm going to turn this into, or I'll do that by subtracting 4y from both sides. So we'll have negative 4y plus 2x is equal to 2. And then I'm going to leave this bottom equation as is. So we'll turn this into 3y minus 2x minus 10, or I guess leave it as such. Now if you look at it, our y's are on top of our y's, our x's are lined up, then we have our equal sign, and then we have our constants. As long as all those things are kind of lined up in the correct series, or in I guess a consistent series, then we can apply elimination. So in this case, I'm looking at the 2's and I'm thinking, oh man, I can just add and be done. So then if we do that, we'll have negative y, we'll have no x's, excellent, and then we will have 12. So that would mean y has to equal a negative 12. Now at this point, 12 is a pretty easy number to work with, so I'm thinking we can plug this back in to one of our original equations. So I'm going to plug it into the top one. It looks like it'd be a little easier to work with there. So we'll have 2x is equal to 4 times negative 12 plus 2. So then let's simplify. We'll have negative 48 here, which would mean that we'd have negative 46 on the right side of the equation. Then we can divide by 2, so x is going to equal negative 23, and that would be our solution there. So be careful. Sometimes formatting is important, or it's always important, but sometimes they can be in different formats. So it's important to line them up if you're going to do elimination. That's kind of the trade-off there. Whereas with substitution, you had to have at least one equation where you'd isolated a variable. So either you got y equals some stuff or x equals some stuff. So there's a little bit of play there. There's a little bit of room for both of them to wiggle. But there are some things you got to have in order to make either substitution or elimination work. And elimination here is probably a simpler method than trying to do substitution with this system, because there would be so many steps you'd have to do first. You'd have to manipulate at least one equation, then you'd have to plug that expression in, and then you'd have to do some serious distribution, serious simplification. It would take a serious effort to do this with substitution. So you've got choices. Go with what's easier, or whatever you perceive to be easier.